This question came in 2017 for 2 marks. The question is, as shown, two silicon abrupt p-n junction diodes are fabricated with uniform donor doping concentrations of Nd1 is equal to 10 power 14 and Nd2 is 10 power 16 in the n regions of the diodes. So they have shown two diodes, D1 and D2, and D is given 10 power 14 for diode 1, and D2 is 10 power 16 for diode 2. And the same thing is applied here also. Accepted doping concentration is as well 10 power 14 here, and in diode 2 it is 10 power 16 in the P regions of the diodes respectively. Assuming that reverse bias voltage is far greater than built-in potentials of the diodes. So this is when we are asked to assume something, we have to be very clear about the assumption so that the answer depends on that. So the reverse bias voltage VR is far greater than VBI. Okay, this has to be kept in mind. The ratio C2 by C1 of their reverse bias capacitances for the same applied reverse bias. So same applied reverse bias is dash. Now C2 by C1 for C2 over C1. First of all, what is this junction capacitance is given by per unit area capacitance I am looking at epsilon over W, the depletion width. So if I take C2 over C1, epsilons get cancelled because both are done with silicon. So epsilons will be exactly same, they get cancelled. So C2 by C1 will be equal to W1 over W2. So given this, now we need to find what is the formula for W. That we know already, that depletion width is given by 2 epsilon. Now we have VBI minus VD, or in terms of reverse bias voltage it is VBI plus VR. Now given this condition, VBI plus VR can be written as VR itself because VR is far greater than VBI based on this condition. Okay, in that case I am simply writing VR over Q times 1 over Na plus 1 over Nd whole power half. Now we need to find what is W1 over W2. Now if I want to find W1 over W2, that will give me the ratio of C2 by C1. In this case, if I take the ratios of two depletion widths, 2 epsilon gets cancelled, Q gets cancelled if I take ratios. And I have given one condition that same applied reverse bias, which means in both the cases the reverse bias voltage would be same. So they also get cancelled. This entire term would get cancelled when we take the ratio. Okay, W1 by W2. What remains is the doping concentrations which are not same as given. So I am going to write here, that is 1 over Na1 plus 1 over Nd1 whole power half divided by 1 over Na2 plus 1 over Nd2 whole power half. This is equal to cross multiplication. I will do Nd1 times Na1. Na1 and Nd1 are given as 10 power 14. So we will have 10 power 14 times 10 power 14 divided by 2 times 10 power 28. So 1 10 power, okay, let me completely write that, which is, sorry, I'll have 2 times 10 power 14 divided by 1 times 10 power 18 if I substitute, because I am adding them here. 10 power 14 plus 10 power 14 is 2 times 10 power 14 divided by 1 times 10 power 18 whole power half, and divided by here 2 times 10 power 16 divided by 1 times 10 power 32. Sorry, this is 28 half. So I can write here 14 gone, this becomes 14, 16 gone, this becomes 16. Okay, 2 gets cancelled. Now I get 10 power 16 over 10 power 14 whole power half, which is nothing but it becomes 10 square over half, which is 10. So W1 over W2 is 10, which is equal to C2 over C1. Hence the ratio they have asked is C2 over C1, which will be 10.